Okay, so there is actually to the previous logical puzzle question that we did. There's a second part to that question, so we'll solve that as well. So here it says A says at least one of us is a knave, and B says nothing. So to like use this statement to determine what kind of people A and B are, uh, I can say so. I can say A is a. So what does this mean? It means at least one of us is a knave means uh, P, which means if A is a knight, right, then P has to be a knave, right? So it satisfies the condition that at least one of us is a knave. Now, or it can be that A is a knave and Q is a knight, right? So again, at least one of the people is a knave, and then, or it can be that both are knaves, right? So this is what actually A is saying. Now we assume that A is a knight, right? If A is a knight, then P is true, right? If P is true, then uh, okay, if A is a knight, then what A says should be true. Like this should be true, right? So if, we'll see if it can be true. So if I now B says nothing, right? So we don't have to worry about that. So if P is true, then this is true, and like let whatever be Q, right? And then this is OR. Now here it's false and false and Q. Okay, Q. We don't know what Q is, or and then not P is again false, and so these two are false, and so that's going to become false. So for this statement to be true, this has to be true. Now, if P is true, then T and not Q uh, should be true means Q should be false, right? So it'll be true and true. So the assignment that can make that true is like A is a knight, right? And Q should be false. It means B is a knave. So since B doesn't say anything, we can conclude that uh, this is true, right? So that's the proof for that. Let's also consider the other case, right? So if let's say if I had assumed that A is a name, which means whatever he says is false or P is false, and then whatever he says should also be false. So P and not Q, right? Or not P and Q, or not P and not Q. So that's so since A is, we have assumed that A is an A, this whole thing should be false, right? Now if I assign the values for P, this is false and something, so that's definitely going to be false. Now this is not P is true, right? True and Q, or uh, not P will again be true and not Q, right? So for this to be right, so if our assumption is correct, A is a knave, then this whole thing should be false. So this is anyway false, so that's fine. Now these two should be false, right? For the whole thing to be false. So which means Q should be false in this case, which means Q should be false here, and here Q should be not Q should be false. So not Q should be false, Q should be true. So now that's a contradiction. So which means we cannot. This assumption is wrong. So this assumption is correct.